Weird Odie doll. Oh, here we go.
Oh,
Okay,
there.
cool.
Oh, yeah. I guess,
That was
had,
slow.
yeah.
Cool. All right. Thanks everyone for joining. Welcome to the demo day of the week. Yeah, lots of things that we want to share. Mostly infrastructure stuff still.
It's like all bug fixes this last sprint.
But
So,
we're like
yeah.
emerging from this bug fixing hellhole we've been in. Hopefully.
Yeah. Are we? Yeah.
Cool. Yeah, do you want to start, Ruben?
Yeah. Yeah. So one of the big things that we made a change, at least for our local infrastructure, is that we actually are now, hold on, sorry. I'm looking for the share screen button. Here it is. We are actually now indexing the universe, as we like to call it. So actually, wait, I guess I'm going to need more than just this. So let me stop sharing this and just share my whole screen. So I'm going to use this nifty tool here. You guys see this?
Yep.
All right, awesome. So yeah, I'm actually now connected to the metrics. But if we just look at staging GitHub events, like this is actually this should be everything starting at 2015 up till, well, last night, I guess, since that was the last time.
Threw a count star in there as well.
Oh yeah. Well,
Is this actually something that runs in a reasonable amount of time interactively?
Run. Yeah, I mean it's reasonable-ish. Actually, how about we watch it? 79% for this min max. Oh well. The funny thing is the percentage does increase because as it finds like new data that it must look at. But it should complete fairly quickly. But yeah, I guess there's really not too much that I need to talk about here. But yeah, I mean everything down to so I guess one of the big changes that we need to talk about while we're waiting for all of this is yeah, okay, maybe the count would have also made that difficult. Okay. Yeah, so one of the things that we need to talk about when you're looking at these models here in GitHub, so the GitHub events, it actually uses a Python model to materialize everything. That's because some of the goofiness that we had to do in DBT, we had this was the best way to kind of figure that out with SQL Mesh. It also provides in and of itself like a set of dummy data, so it can always be materialized locally, like no problem. So that's also quite useful. But
Sorry, why does it have to be a Python model?
Oh, so the reason it had to be a Python model is what exactly happened here? Oh yeah, so the tables, so it's a Python model. It's a Python model that emits a SQL model. But the reason for this is that GitHub archive writes things to tables. Like every day is a different table, or every month is a different table. And Trino doesn't have a good way of doing like partitioning. If you set like if you do the star based query, so it will scan more things than you want it to. At least I believe that's what was happening. So in order to get around that, I use a Python model to generate the table names and then union like 3 months worth at a time. Up to 3 months worth at a time. and then it just does that for all of time. But on like the latest day, it just does a very simple query. So it's not a Python model in that it's not data frames. It is generating a SQL query at the end.
This union selects thing,
Mm-hmm.
the union also works. The union is in SQL? Is that how
Yeah,
that-
yeah, the union's in SQL. Mm-hmm.
Oh.
Yeah, actually, I took this, little bit of code from Javi's work.
I see it. Okay, got it. Okay, I see it now. Awesome.
Yeah,
Cool.
yeah, it was
Very
a
cool.
cleaner version of something I had done previously. So, yeah. Oh yeah, this query is actually still going. That's how large this data is. So you never mind. We're not going to see the end of this here. But yeah, so the things to be mindful of is that everything before it gets to metrics is the universe. So anything you do here is a very large thing. So make sure that you set, try to be incremental. I set the batch concurrency now from like 1 to 3, so that allows it a little bit more speed. So you can run, 3 of the increments at once, and then it'll try and write all of those, as they finish. So, but yeah, that's kind of it. Oh, one other thing, actually, set these incremental the starts to using these nice little nifty macro variables that I have in here now. So
Ruben, real case study.
yes,
We had this model that was huge, called, I think, in developers by repo or something like that. And the goal was identify for every kind of developer repo combination when was the first time they made an event. I think it was like every possible event. So it was those things.
That will be massive.
Massive, right?
Yeah.
Let's just say that I want to do the exact same version. I won't, but if I want to do the same version, how would you recommend setting up the model parameters for something like that?
Ooh, man. Yeah, I mean, at least with the current query runner, that might be like very, very difficult. Query runner being Trino, I don't, like we haven't sized our machines super massively. So we're actually like kind of still sipping. So if you can figure out how to increment, if you can figure out how to split these things into multiple partitions, that would help it out.
Right.
So if you say, I know that this is something you can do. You can do like a hashable, like, the developer logins and things like that, and then try and split up the problem even further. The best thing probably for us would be in that specific instance, that's where I would use the int artifacts to maybe only scan projects that we care about.
That's what I'm going to do. But if I wanted to do the whole universe,
if you wanted to do the whole thing, I don't yet have a good answer for doing it, wholesale. I think there are some things that would be nice if each individual trainer runner could spill the disk a little bit. That would be useful, but it's not something that's configurable. You either have spill to S3 or spill the disk. So, which is kind of a sad thing, state there. But yeah. So I don't have a good answer yet.
Okay. Well, I guess the answer is just don't do it. Which is
yeah. I mean, the best answer is try not to do it. But I mean, test things, I guess. I'm cool with us testing it. It's not like it's not like BigQuery now. So now that all the GitHub data is basically ingested, basically everything is not so the cost is not about scan. The cost is about wall time more than anything. And even that, as long as you're not as long as it's not using all of the nodes possible and it's not like multiple days, like it should still be fairly reasonable in cost.
Amazing. So. Yeah, I still need to get used to not having the mindset of being very, very cost conscious every time I hit run.
Yeah.
Cool. That's fantastic.
Yeah, but that's all I got really, unless this
Oh,
query
can you
finished.
also
Oh, it did.
demo?
Actually.
Can you demo Icaros Trino stuff?
Oh
He's,
yeah.
he's unable to join.
Oh yeah, and so this is correct. We do have up until today.
Nice.
We have the universe. I should have done the
On
count.
some level, that took a really long time, but less time than I expected. On some
Yeah,
level.
yeah, exactly. Yeah.
Like,
I mean, again,
you're
like,
spinning like the
the
entire.
nodes that we're running are like probably like a quarter or less of the size of what BigQuery runs in its cluster. So
Yeah.
massive cluster. So
But also,
okay.
yeah, considering that this is basically across all GitHub events, right? So it's
Yeah.
like that's pretty fast.
Yeah, I mean, GitHub would be, Google would be way faster, but yeah, we're not bad. We're not bad. Okay, so yeah, I guess we can talk about this. I don't actually have it running locally. I've just been relying on it running in CI, which has been pretty great. So I guess we can kind of poke at this really quick. One of the cool things that they're like probably my favorite feature as of late is it hasn't been running here recently. You have to look at a closed PR. I can't even look at these things. Okay, so it's we have local. We changed how local Trino is functioning now. We use what's called local Trino Docker, as opposed to local Trino, which runs on Kind. This is significantly faster, so the startup time is much less. Actually, let's I guess give it a shot. Let's see if we can run this.
Have we updated the README to include?
That's a fantastic question. Let's see. Did we update the README? We did not. We did not update the README. Docs need to be updated.
Yeah, read me.
Yeah, so I will add that issue. Yeah, and so one of the things also when we did this is, I think we want to rethink where the Docker Compose stuff in general goes, because we had most of the Docker things in here, but that may not always make the most sense. Yeah, I left it up, sort of punt on the decision where to put this for now. Probably should have just had it go into the main place, but that would have meant renaming. So I think that should be fine. Ooh, sure is. Nice. Yeah. So basically, the thing that this does inside of Docker Trino, it has a seed, which currently is just SQL files that actually, instead of using like the Faker setup, we actually just introduce like fake data that that is modeled from the real data. So we might actually change this to be like Python so that we can, code around this a little bit better or use this as well with Faker. Yeah, in a generative way. That is something that we discussed, but we wanted to get something that worked very quickly, really quickly. So this is where we are. So now, yeah, actually, this is all running. So you can see Trino is just starting up, and wow, that's very fast. The flux would have taken at least another minute, or 2 or 3. So if we do this, so local SQL mesh. Oh god, let's see if this works. Local Trino Docker. Nice. Sorry, this is probably not the most simple to read there. Maybe that's a little.
So the dash local trino, does that still go to kind? And you have to specify.
That still goes to kind, yeah. We'll change some of that stuff around. But yeah, that one would still go to kind. So I actually don't usually run this on my Mac, but I'm running on my Mac so I don't mess up my development environment. Oh God. Oh yeah, of course, because that file doesn't exist.
Yeah.
Yeah.
Right.
Well, I don't want to open that up here. There's potentially secrets in there. Okay. But yeah, that's all you would have to do. I promise it is much faster. If you've seen it running in CI, it's currently optional. It is it's about the same length of time as running all the node CI. So like somewhere between 3 to 6 minutes, something like that.
Like, since it's running in CI now, as long as it's optional, like, I guess in theory, it's not actually strictly necessary to run it locally unless you're debugging.
Correct.
Right?
Yeah. So I would say that, yeah, you can still continue to do the DuckDB. In fact, you should still just use you should still continue DuckDB local. And then, yeah, we will make it not optional in CI. And at that point, it'll catch many things that you do. Some of the stuff that you may want to do later on, and actually, maybe we can go over this very, very quickly right now. But one of the issues that we ran into this past sprint is around like artifacts by project OP Atlas. So I was just testing this locally, but you can actually put an audit. They already have these like built-in ones. You can check not null columns. So yeah. If you just start adding these things into certain things where you know that we're either cleaning data and you want to check it, like this is actually the perfect place to do it. So, but yeah, this will all run with the Trino setup and with DuckDB, and we'll be able to check that things work in both cases. So if you write an audit and it runs in DuckDB, and when it goes to CI, it will try running in Trino. And if it works correctly, then the CI job should pass. Yeah, I guess that's all I got here.
Sweet. Is there any running local Trino via Docker or Compose to debug anything? If you get a bug in CI/CD, is there any reason to use the kind setup?
No, not at all. Yeah. The only reason to use a kind setup is if you're doing infrastructure stuff around.
Yeah, I guess when we update the README, we might still need it. So I guess we can probably.
Oh yeah, I mean, I'm not getting rid of the local kind setup.
Right.
I definitely will want to test things for infrastructure, so I would like to keep that there.
Yeah.
But yeah, I don't think we need to be running that continuously via CI necessarily. So, or if I would run it in CI, I would run it periodically, so that way it doesn't get stale, but still works for testing. Yeah, but that's everything.
Cool. Javi, you want to go next?
Yeah, awesome. Okay, so window, there you go. Perfect. So basically I want to show these new utilities that we actually got working on the last sprint, which are this process chunk resource and this DLT parallelize. So for those of you who don't know what it is, basically we have a super specific problem. That is that we didn't have a way to control how fast our processes run. For example, when we are extracting something from an API, we were just letting things run until we hit a rate limit, and then we just waited until it cooled down. The thing with this is that it is dangerous. We can get our keys revoked, and it is not ideal. So that's why this first DLT parallelized one comes into play. So basically, you specify the chunk size, which means like how many items will be in like one chunk, how many batches you want to run in parallel, and how much time you should wait in between interval. The cool thing about this is that it allows us to exactly respect, for example, GitHub limits. So basically, this does like around almost 5K requests per hour, which is their limit. So it means that we basically do not run into like a 429 ever, because we're just like, going under. So our tokens are safe and we have a lot of granularity. And this DLT parallelize is super nice because we can use it in conjunction with this process chunk resource. So what does this thing do? Basically, we had a problem. We have some long-running jobs, for example. So SBOMs, the software bill of materials, for those of you who are not familiar with it, is basically like a manifest of which dependencies a project uses. And that is super interesting data because this allows us to see a lot of cool things in dependency management. We use that, for example, in deep funding and a lot of things that we are doing currently. The thing is that we have like almost 120,000 repositories, and each of these repositories need one call for the SBOMs, which means that the job is like more than 24 hours long. And compute is actually expensive, so these jobs were costing us a lot of money. There's this thing which is called a spot instance, which is basically a type of machine in which our code is executed that is like way cheaper. The thing is that it can be like killed at any moment. So we added this process chunk resource, which basically allows us to make our script fault tolerant. So if it fails in the middle, it saves all state until that point in GCS, in Google Cloud Storage, and then it retrieves everything and it actually makes it work. The thing is that it has some caveats. Basically, let me show you how it works. When you do one of these like at DLT factory, you need to return a resource, and that's exactly what this does. And it tags this chunk resource config. So basically, you need to pass a fetch data function, which will be run once the first time, and it will fetch like all the data that it needs to fetch. For example, if I want to fetch all SBOMs, I need a list of all repositories. Then this fetch data function, that's what it does. If I want to get all repositories, I need to fetch some data from OSS directory. That's what it does. So this will only be run once, and then it will be saved on GCS. The resource is the resource itself. So basically, a resource is like a subset. It's like a small unit in DLT, which allows us to fetch like one API route, for example. In this case, it must return a coroutine. So basically, the rationale behind this is that in Python, when you consume a generator, function inside run and get consumed. The thing is that if we return a coroutine that hasn't been evaluated, we are able to like chunk, move things around, play with generators, and that's how we actually do our magic. So we are returning a partial. So basically, we are binding the owner and repo to like this get SBOM for repo function, so that when it is called, it is actually bound to those arguments. So basically, this is a list of functions that, when executed, call the SBOM function. And after that, we need to have a string function, which will allow us to serialize, because maybe we're returning a Pydantic model, or it's returning something that's not easily serializable and savable. So that's how it works. Here we run the model.json, and then we need to pass the GCS bucket name for us to store all the data and context for logging. And then all of these functions here are passed to like the resource. So for example, this resource takes a GitHub token, so that GitHub token is passed by that. Mainly, one thing that you have to be aware is that if you don't want to use this process chunk resource with one of the DLT parallelized decorators, the implementation detail is that there is these two functions, which are called chunk resource update and chunk retrieve failed, which need to be executed once we update the chunk or we retrieve all the failed ones. This is already handled by you in the DLT parallelized, which means that whenever it processes a chunk, like an amount of, for example, 80 elements, which is like 16 times 5, which is like our limit, it will basically call this chunk update function, which uploads to GCS, uploads the manifest, uploads the counter, everything, and saves. And then if it is like the last run, what it does is it basically retrieves all the failed runs, and then it uses, and we have like all the data that has failed in other runs. And then it cleans everything up for you. That's basically how it works. So I really strongly recommend both of them to be used in conjunction. They are a really powerful pair, and they allow us to like save a lot on costs and make everything, how to say this, more scalable. I want to like highlight and say again that for it to work, it is important that it resolves to like partial coroutines, which basically need to be called like a function like this. It must not take any argument, and that's how you do it with a partial. To like, you know, as I said earlier, move all the generators and be able to batch everything. But yeah, this is basically how you write. We now have the SBOMs and the repositories for like OSSD written in this way. So they are like way cheaper, and they use this approach. Yeah, I mean, I think in the future, if you have a long-lasting job, you should write it this way.
Can I ask a quick question?
Yeah.
For DLT, like, I'm just kind of surprised that the underlying library doesn't have any particular mechanism for handling, you know, like basically controlling your parallelization and your rate limits and whatnot. Like, does it not? Like, yeah, I'm curious, like, what kind of built-in facilities do they have? Because, or do they just assume that you just hit a rate limit and there's some kind of exponential back off?
Yeah, so basically how it works is that they do have one thing, which if we go, for example, to the DeFi Llama one, it is this parallelized flag that basically tells everything to run like in an async pool. The thing is that there's no way to control how it gives us no granularity. It just launches everything in parallel until it fails or it executes, which is like not what we want. So that is why like the DLT parallelize exists, because like this is the only thing that we can tell it. We can tell it to like run in an async pool, but we have no control over like, hey, we want to run this, you know, every 5 seconds, every 10 seconds. We want to run this in parallel. We just tell it this. So no, there's no built-in way, which sucks. Let's be honest.
Yeah,
But,
I think it's like
yeah.
it's one of those things where if we had more time, you know, we might even want to upstream something like this, because it seems pretty. Like the chunk resource is hard because like the fault tolerance is something that's like very specific to how we manage state, but like the parallelized thing seems like very independent. That like they like seems very general purpose, and like no reason why that shouldn't be part of like the default DLT library, right?
Yeah, I agree.
Yeah,
The thing is that,
yeah. I mean, even a quick look through the docs does not return anything around rate limiting like settings. So there's just, yeah, it's not there.
yeah. Like I've been having to dig into like the internals of DLT. I've been reading the documentation a lot, and everything that it is like parallelization related, they haven't done a really nice job. It is like the library is thought to be like run sequentially, not at the same time, because like their state doesn't use logs on everything. So basically, they just overwrite the stuff, and they just give you workarounds for you to like use a different pipeline or just do them in another way. So yeah. Parallelize wise, we have to like do a lot of the tooling ourselves.
I saw you updated OSSD repositories to also use this, so that is awesome.
That is correct.
Yeah,
So
I mean,
I dropped...
ideally, what we could do is, now that we're indexing the universe, you know, we could have like the prioritized job, which is all the stuff from OSS directory, and then maybe like a job that just collects as much as it possibly can all the time.
Yeah, we could do that.
Other repositories that we have, because it would be good to get different metrics for those things that are not being quote like tracked by us directly. But some of that information is useful, right? Like if we were to put that into a separate database, you know, for the non-OSSD things that we wanted to collect. So
interesting idea. Yeah, I have some ideas for how we might come up with an order of what to, like a list.
Yeah. Because we also need to do that for OP Atlas stuff, I would guess.
Yeah, that's I don't know, like 5 minutes or something, because it's mostly a subset of things that we already have in OSSD.
Yeah. I mean, do they do any, like on their side, actually, does OP Atlas give us some of the, like the GitHub repository IDs and things like that we would
No, they just give us they ping the...
Are they willing to make that API call so we don't have to do it? Because, you know, it's only a single API call, like when they get the data from the user, I guess.
Get
right?
the node ID, you mean?
Yeah, like basically just like if you did get repo from against GitHub's API, like we just need that entire JSON. That would be very useful. So.
Yeah, I mean, we can see, because we have that in their repos table. We could probably ask them to add some things there that we want.
Cool. Yeah.
Personally speaking, I'm curious, like, why we wouldn't just do it ourselves. Like, I feel like relying
Okay.
on
Yeah. Okay. Let's just do it ourselves. Yeah. Let's just do it ourselves. So.
It's like 500 repos. It's nothing.
Yeah. Okay. No, that's really little. Yeah, we could do that in less than 30 minutes. So. Okay. Never mind. Never mind.
I mean, unless it's like really, there's a strong reason why it should be in the front end. Like, okay, we want to do some kind of validation, or I don't know. Yeah.
Yeah.
Anyway.
Okay. Yeah. Cool. Awesome.
Yeah, Carl, you want to share?
Thank you for coming.
Yeah.
So,
Oh, don't leave. We got more. Oh, I see. You are leaving. Because I think that Angela would have liked what I was about to share. So hopefully she watches the recording. If not, I'll follow up. Okay, so all of that infrastructure is being put to use right now as we try and spin up the metrics for the latest retrofunding on-chain builder round. What I'm going to show you right now is kind of the end state, which is that we have a whole bunch of models that are built on top of everything you just saw. And the goal is to arrive at a set of metrics that we can use for retrofunding. Right now, there's two different rounds that are going on, one for on-chain builders, the second one for dev tooling. I'll just show some examples from the on-chain builders one. So the first one, this is just my setup for connecting to production Trino. I'll just kind of run everything fresh so you can see. Very simple, very clean. I like it. Hopefully soon we can wrap this in OSO and it becomes even easier. But for now, it's pretty simple to get going. The first thing I'm going to do is actually just check that we are getting everything from OP Atlas correctly. So this is the one of the interfaces for looking at all the products that have applied for retrofunding. We can pick a product at random. If anybody sees something that looks interesting, let me know. Yeah, why don't I do Superfluid actually? So I'm going to grab the project name, which is this. Oh, sorry, you can't see it, but there's a name of the project that I'm going to grab, and I will drop that in here. And so now I'm basically just going to query our new unified artifacts by project model and see if we get this project having applied for retrofunding. So this is the round ID, which is number 8, and this is the first measurement period. So 8/1 is the name of the collection. And all of these are namespaced under OP Atlas. Artifacts by project is huge now. So, and we haven't done any indexing. So we need to actually put some indexes and some partitions on it so it will be quicker. Right now, it's just like a...
Why is artifacts by project huge?
Mainly because we have a lot of artifacts now.
Like, why would it be bigger than before?
Yeah, because it interjoins in the project. So unless I guess we're also interjoining against
like previously in
Atlas.
OSIS directory, we imported a bunch of stuff, right? So we already had a lot of artifacts.
I mean, sorry, I should say it was 50 gigabytes before. Now it's like 100 gigabytes. So
okay. I was thinking like multiple terabytes.
Yeah, I mean we can see it just ran. let's see how much that consumed. So okay, yeah, not big. About 40 seconds of wall time. All right. Anyway, so that ran. Superfluid. It brought us back. Yeah, a whole bunch of contracts. The thing that we are doing, which is important to note, is that we basically look at any contract here, which is a factory, and identify all of the downstream deployments from that. So as you can see here, they have, I don't know, maybe 100 or so contracts that they've listed. But then in our version, we actually get everything that is downstream from those factories. And so it's many more. I'm guessing any Superfluid token stream is now showing up here. So we have more than what they show. And let me just update that. So that's kind of a quick test to see that things are working, and they are. I won't run this now, but overall, for all of the projects that have applied for the on-chain builders round, there's like 1 million artifacts that are relevant. Most of them are on Base, but you can see all the different chains. We now have this working. Obviously, there's 18 or so chains that are relevant for the round. We have the GitHub forecast for Twitter artifacts as well. Everything is working beautifully right now. It took a while to get here, but it's amazing now seeing that we have correctly ingested a second source for projects and collections. So one of the first models that we need to apply is a check on eligibility requirements. So in order to be included in the on-chain builders round and be eligible for rewards, there are some thresholds that have been set around number of days of activity, how many transactions you have, how many active addresses. Gas fees is not actually a constraint, it's just something that we check. And so we can look at the eligibility model, and we can pull up the project, and we can see if projects are eligible or not. I was afraid to run this the first time, but actually everything came back and makes total sense. So you can see here that these are all big projects. It's no surprise that Uniswap and Aerodrome, Virtuals, etc., are appearing at the top of the list. This is a new project on WorldChain. It's very, very popular. There are some unique things on WorldChain that make it a little bit difficult to get active addresses. Basically, every user on WorldChain is a safe, and it's a one of two. So it's either the WorldChain Foundation or the user that has signing authority over the safe. And so we're not capturing all of the active addresses or all of the active users correctly for WorldChain just yet. But for now, we're getting the other things like transactions and gas fees and so on. I think this is fine. But basically, we're getting all the projects this way. We can also see which ones are falling below the cut. These are mostly, scammy projects or things that really just don't have much activity. And you can see that they're falling through, which makes sense. And the last thing I'll show here is that we can also query the metrics. We can see the 4 metrics that we care about right now. Soon we'll add DeFi Llama to this, but we can see for each project, its results for the last 3 months. We can go farther back, but the last 3 months are all that we care about for retro funding. And these numbers look correct. I've checked them, and it seems like everything is working. So again, it feels almost embarrassingly simple that all we're doing is just like querying this thing. There's so much upstream of this that had to come together that when you can actually get this kind of data back from just a few lines of SQL, it's pretty amazing. So yeah, excited to see this. As I mentioned, the missing piece still is the DeFi Llama data. Right now, we're only going as far back as March the 7th, but that will be fixed soon. And yeah, just a quick check to get a sense of how much data we have in here. So this is everything coming in from the artifacts table. Right now, these are all of the different sources that we have. You can see what is uniquely in OP Atlas, what is in OSS directory, and what is kind of shared across both. And it's a lot. There's a lot of artifacts in here.
Cool. Remind me again here, how are you querying? Is this like a Trino client directly?
Yeah, I'm querying production Trino. So I'll run this now.
Production consumer Trino?
Yep. So
through Tailscale?
Yep, here it is.
Got it. Okay. Yeah, excited to get this on PyOSO so that we can share it.
Yes. And then if you want, I could show you what it looks like when I run it locally. I guess we already got that demo, but if you want to see another person do it, would that be helpful? Anybody want that?
I think it's fine. Like, we're going to refactor all this like this week, hopefully.
Cool. The one other thing I'll share that I didn't put on the list, this is actually intended for Angela because I know that she wants to start getting involved in some of the data work that is required for improving retro funding. But we have a number of issues that have been opened up on the retro funding repo. There's also some bounties that are going out to the number nerds to participate in these activities here. But we, for example, one of the things we want to do is compare the results of our algorithms against a pairwise assessment that different maintainers have made about dev tools. So ideally, someone can come in, look at the results, compare that with the voting results from pairwise, share that here, and start giving us some feedback on how well our algorithms perform and identifying areas of improvement or places where the algorithm is really out of line with what experts are expecting. And I think that's everything that I had. Yeah, there's a few more issues that are going to be coming up here. But hopefully over the next month or so, we'll get some external contributors taking these on and improving the algorithms for retrofunding. Any questions?
Well,
Hey, guys.
I guess the main. Oh, sorry, Mohammed, go ahead.
Yeah, so yeah, Carl, you mentioned Angela, so I'm working with her on this evaluation algorithm stuff. So yeah, we have done with the first iteration where we use dummy data of metrics, and right now we are looking for actual data. So we were struggling with that,
Yes.
and I think you already answered that, but just for sake of clarity, I want to know that what is the best way to get that data from Trino, OSO, or GraphQL API? So which one is like for the round 7 on-chain builders time series metric data, which is the best source?
Yes. Very soon it will be OSO.
Okay.
I can share. Let me just share my screen again. I think we demoed this last week, but we have a Python library that we are building out right now, which will allow you to query exactly what you just mentioned. So you can come in and get time series metrics. And I'll give some more examples of how to like identify the project that you want and the metric that you care about. But in general, this will be the pattern that you would use. Come in, connect to OSO, and then figure out what metrics you want over what time period and for what projects.
Perfect. So is it the most recent data set available?
So a lot of what we've been doing the past month or so is doing an overhaul of our infrastructure so that we can actually have these metrics running at a much lower cost every time we run the indexer. And so right now we have not fully connected everything. We are very close. I hope that like the next time you come back for demo day, we'll be able to show that. But as soon as it goes out, we'll make sure that we let folks in the TE community know.
Perfect. So it's OSO.
Yeah, BIOS. I mean, you can pip install it now. You can test it out. It just won't have the latest data just yet. There'll be some holes in it.
I mean, for what it's worth, like the API should be connected to the same data. So, I mean, it is connected to the same data right now. So if you're only looking for MART models, so you only care about the time series metrics, you only care about the projects, and you prefer to connect it to a production app, then the API is probably easiest. It's a GraphQL API. And all the documentation is available for that as well. PyOSO is mostly if you want to access it from a Python environment, and if you want to be able to have access to the full production Trino cluster. So you want access to all the source data and all the intermediate models and all the everything, then that's the easiest way to get access to everything. But if you just want the metrics on the other side, the API works as well.
Perfect. We needed it in Python environment because we were running some simulations. So for that, PyOSO, I think that is perfect.
Great.
My question for you, Carl, is how do you think right now in terms of the interface between, like, when you did the evaluation algorithm stuff, like you had a bunch of metrics on one side in the pipeline, and then the evaluation algorithms themselves were in notebooks, right? I don't think you actually wrote models for them.
No. There are models, yeah.
Oh, they're SQL mesh models.
No, they're not SQL, they're Python models, but they should be able to run. All we have to do is, instead of using a CSV, just use the relevant query.
Yeah, I guess I'm wondering, I guess what I was trying to understand is because I know we are trying to juggle between the stuff that we have in our pipeline and this optimism retrofunding repo that we have to maintain, right? And I'm kind of curious where you see the interface of like what lives where. I mean, obviously it'd be easier for us if everything was in the pipeline. But is there anything that wouldn't be in the pipeline?
I think that obviously, you know, our pipeline is going to be the source of truth. I want to do probably every month or so an update to make sure that the latest model is also available there for people to run locally. On-chain builders should be, you know, literally just one model, one Python file. And my intent is to have this running in production as well. And then we just create a copy of it here. And there's like a utility for getting data from a CSV as opposed to getting it from the, you know, directly from our SQL.
Okay, cool.
Yeah.
All right, well, let's call it here. Unless anyone else has any questions. Awesome. Thanks for joining, Al.
Ciao, ciao.